fractions. What else we gonna do? Divide fractions. Rational numbers are fractions, okay? So if I go like this to you right here, come on over, let's go 2/3 times 3/7. Okay, this stuff, this was given to you by, well, I'd say 5th grade, somewhere in that area. How do they teach you to multiply fractions? Louder. Say it again, Riley. Crisscross. So cross multiplying? Do you know the answer to this, guys? If I go like this? 6 times a half.
13.
What is the answer? 13?
Around 13.
Isn't it 3? Half?
Yeah.
Isn't half of 6 3?
Yeah.
Okay, so if you know the answer is 3, then, if you want me to cross multiply, I'm going to get what?
12.
Well, 1 times 1 is 1, and then this is 12. So the answer says 1/12. Cross multiply, is that really what you do?
No.
No, don't you go 6 times a half? Don't you just multiply what? Straight across, get 6. Straight across, get what? 2. What's 6 divided by 2? 3. You guys, the answer is straight across. That's what your 5th grade teacher told you, so you can't forget it. So we can go straight across, and get what? 6 over 21. But 6 over 21 reduces to what? What goes into 6 and 21?
3.
Okay, 3 goes into 6 twice. 3 goes into 21, 7. Okay, so the answer is 2 sevens. Now hang on. Could I have got that answer so much faster?
Yeah.
How?
Cancel them out.
Yes, you guys. Or could I have just said, this is 2 times 3 on top over 3 times 7 on the bottom, but really, doesn't a 3 over a 3, if they're the same number, don't they just cancel out? So then the answer would be what? 2 sevens. Look how quick I got that answer. I got it super quick. So my suggestion to you today is, please cancel anything that's the same on top of each other, okay? Whatever on top, whatever on the bottom, if they're the same, go ahead and cancel. Do you remember this from Friday? So if you have a binomial x plus 3 over a binomial x plus 3, what happens? Yeah, it's the exact same number. It just cancels out. You put 1 over 1. Okay, if you would have had a monomial in front of it, 3x to the 3rd over 9. Oh, let's just say x. What would happen here? What was the answer? 3 nines, 3 nines, 3 nines. Reduce it.
3x.
Okay, guys, what goes into 3 and 9?
X. 3.
What goes into 3 and 9?
3.
3 ones and 3 times. So to me, the answer is 1/3. Okay, but x on top over x on the bottom. Didn't we say cancel one of those x's with one of those 3? What would be left? Yeah, x squared. And the rule was take the exponent 3 on top minus the 1 on the bottom, and you get the x squared on top. Does that make sense? And that's the answer. Okay, do you remember this? If you ever see, let's say, x minus 7 over 7 minus x. Okay, what do I do here?
Oh, it's flipped over.
They're what?
Flipped.
No, they're not flipped.
Opposites.
They're opposites, yes. If this number is x right here, and this is negative x here, those are opposites. If this is negative 7 and this is positive 7, guys, those are opposites. As long as you have opposites over opposites, go ahead, cancel them. And don't put 1 over 1, put what?
1 over
Yeah, I usually put my negative with the top. I do. Okay, so be careful on that. All right, that's going to happen again today. All right, come on back. Come on. Oh, geez, where'd I go here?
Did we do a worksheet
No, you did delta math.
Yeah.
Okay. Now, here's my next question. How do you do this? How do you divide? How do you take 6 divide by a half?
3.
The answer's 3?
Yeah.
Okay, Matt says the answer's 3. You guys okay with 3? Yeah? Okay. So you know that number 6, guys? Think of, you have six pizzas. Okay? Must be Super Bowl weekend. 6 pizzas divided by a half. When you say divided by, you're saying this. How many times will this number go into this number? Well, how many halves are in one pizza? 2, 4, 6, 8, 10, what? 12. Guess what, Matt? It's not 3. The answer was 12. Now, wait.
Quit touching me.
How do you get it?
I don't know. I just divided it.
I know you did.
What? You divided it wrong.
How do you get it, guys?
Flip over. It'd be
Flip.
6 over.
Okay. So, Aiden says take the 6. He says flip this over, make it 2, and then do what?
You put the 1 underneath it.
Well, okay, I can do that. But what am I going to do?
Flip this up.
You multiply. So here's what you do when you divide, guys. You don't divide. You never divide. You only multiply by the reciprocal of which one? The first one or the second one?
Second one.
Okay. Or say it this way. Always multiply by the reciprocal of the denominator, the one you're dividing by. Okay, so the answer is 12. Okay, so there it is. Now, do this problem, please. Make it a little tougher on you. All right, how about a 2 sevenths and a 6 fourteenths? 2 sevenths and a 6 fourteenths. Do a little bit of division on that one. Okay. Well, if you were listening to me, you're not going to change the 2 sevenths, but you're going to change your division sign to what? Okay, multiply by what?
14
Okay, 14 6, gotcha. Now wait, you know how to multiply because we just did it up here. Top times top, bottom times bottom, but wait a minute, look to what? Yeah, but look, I was going to say look to cancel first. Like, see that 7 down there?
7 and 14.
7 goes in 7,
1 9.
7 goes here.
2 X.
Okay. 2 goes into 2, 2 goes into 6, once here, 3 times here. What's the answer?
2.
Yes, it's 1 times 2. That's 2. It's 1 times 3. That's 3. The answer is 2/3. Right? Are you guys okay with this? Okay, keep going. Now we start our problems, all right? Okay. If you remember on Friday, I said monomials can cancel with monomials. So that's all you have is monomials. So let's go, oh, what happened here? Okay. So this one, I would personally just do this. You multiply straight across, but you're looking to cancel. So guys, what I would probably do for you guys is this. I'd take the 5x cubed, I'd write it out, times, that 6 can be changed into 2 times 3 times x squared y. What I'm doing is breaking apart the numbers for you so it's easier to cancel. Okay, this 2 on the bottom is already broken down. I'm just going to leave this as is. That 10, I'm going to rewrite it. How? 2 times 5? Okay. And then at y squared? Okay. The reason I did that is because now I can see things in front of me and I can just start canceling. What do you see? This is all multiply, guys.
2.
What?
2.
2 with a 2. 5 with a 5, right? Okay, now I'm going to clean up the mess a little bit. On the top, I see I have a 3. X to the third times x to the second is x to the fifth, yep. And then a y. On the bottom, I see I have a 2. X. This x, yeah, y to the what?
4.
Fourth. I'm getting why. Oh, I said that wrong. Why. Good? Matt?
Yeah.
It's hard for people to listen. It just is. Okay, 3 and 2 is reduced, guys, but what about this x over x and y over y? What are we going to do? Doesn't that 1x just disappear with one of those? What's left?
X to the 4.
3x to the 4th, yep. And doesn't this y right here just cancel out with one of those y's?
Yeah.
So what's left?
Y to the 4.
Over 2.
2y to the 4th, isn't it?
Yeah.
So where are there more y's on the bottom? Where are there more x's on the top? And that's why the x's are up here and the y's are down there. Yes or no?
So this is like a finished equation.
It's a simplified fraction. I reduced it. I took that times that, and then I canceled, and then I looked at what I had left is a bunch of x's over x's and y's over y's. Okay? Now, I will tell you this. Monomials are not hard, but they're very, very messy. That's a messy problem. I almost like it better when it's binomials and trinomials because here's the thing. All you got to do is factor them and cancel out likings. Okay? So here's the problem. Binomial, monomial, trinomial, trinomial. The only thing you can touch is the tri with the tri. Are they identical?
Excluded.
Well, no. Identical means that they look exactly alike.
Oh, no.
No. Guys, nothing up here is going to cancel out. But we said on Friday, try to factor everything you can see. There's one problem up here you can't factor. Which one? No, binomials can be factored, so can tries. It's the monomial, 3x. You can never factor a monomial. Just rewrite it. Okay, now help me on this. What on top left can be factored?
Up left.
What can you take out, guys? GCF.
Oh, 3x.
3x comes out. What's left?
3x. No, x stacks.
3x goes into 3x once. 3x goes into 3x squared. What's it going to be? Minus x, yeah? Okay. And there it is. All right. Sorry, I got to get rid of this, guys. Lower left is going to be a trinomial. Trinomials, these are pretty easy trinomials. Give me two numbers that multiply, give you -5, but add up to 4.
What? I don't know. Oh, yeah.
5 and 1, but what kind of 5 and what kind of 1?
Positive 5 and negative. Yeah.
Okay, positive 5 minus 1. Gotcha. Okay, how about the next trinomial in the upper right? 4 and 5, okay. Okay, and then what? What kind of 4, what kind of 5?
X plus 5 and x minus 4.
X plus 5, x minus 4. Gotcha. Okay, now, you guys, I came in here saying, how do you multiply? And we struggle. How do you multiply? You do top times top and bottom times bottom, but don't until you cancel. Now, anything the same.
X plus 5.
X plus 5 with an x plus 5. Okay, hang on. This guy?
Yep.
This guy.
And 3x.
Oh, every time I do this, I should be putting ones here. Okay, what?
X, 3x.
Monomial with a monomial, 3x goes out, 3x goes out, 1.
X minus 1. Oh, no. They're
Okay, x minus 1, 1 minus x. They're what?
opposites.
They're opposites, so if I cancel them, I got to put 1 over 1, but make this one negative. Hey guys, that's about it. There's nothing left but an x minus 4 on the top. So here's what you do. You multiply the top. What's a 1 times a negative 1 times a 1 times an x minus 4? Isn't it going to be -1 times all of this?
Yeah.
Okay. What about the bottom?
It's
It's 1 times 1 times 1. It's just 1. So guys, you're staring at the answer. This is the answer. Although some students will want to do this, run this through and call the answer this.
But isn't that a monomial, so you can't touch it?
No. I'm not trying to cancel things. I'm just saying this is the answer, Matt. But Matt, if you did run this through, this would be the answer. It's one or the other.
Well, so if,
Here's my point. I would say right there, just stop. Why are you doing that? Why are you multiplying through when it's the same answer? Right? So I would just stop right there. That's me. If you do this on the test, I'm not counting that wrong. I'm just saying you did too much. Okay. All right. Come on down. I don't see a fraction on the second one. How do you make that a fraction? Put it over 1. There you go. Okay. Multiply. Well, binomial, binomial, trinomial. The two binomials are not the same. I guess we're done. No, we're not. Factor it first. Look at it again. Cancel if you can. Okay? Here we go. This one's easy. I got the 1. Oh, what about an x plus 3? How do you factor an x plus 3? How do you factor an x plus 3? Is there a GCF? No. Is that the difference of two perfect squares? No, it's done. X plus 3 is done. Okay. It's the other two that can be factored, okay? Anybody happen to know this one? Two numbers that give you -8 when you multiply, but add up to 7. Okay, 8. 8 minus 1, okay? I like it. Yeah, he got it. The bottom. What do you see in the bottom left? GCF is what?
2.
2. Okay, take out 2. But when you take out a 2, what's left? Okay, okay. Now do not stop. Look inside. What do you see? Two perfect squares with a minus in the middle, which is called the difference of two perfect squares. Your best friend. Factor it in 10 seconds. 2 times what instead of this? X minus 8 times? X plus 8. Got it. Okay. Now you're done factoring. Now can you actually cancel things out? That's the question. What? X what? X plus 8 with an X plus 8. Got it. Got it. What else? That's a binomial. That's a binomial in the back right here. Yeah, I don't see anything else, right? That's a 2. There's your monomial 2. Up top, I got a monomial 1 and a monomial 1. That doesn't help. So I guess we're done. On the top is what? Times x minus 1 over 2 times x minus 8. So all that factoring you and I did, it only helped us right here. X plus 8 with an x plus 8. Sometimes you get lucky, everything cancels, and sometimes you get kind of unlucky, nothing really cancels out. We did get one factor that canceled. Okay, here we go. This one's got quite a bit of factoring. Go ahead, start. Get ahead of me. I mean, the top two had GCFs, right, guys? Whoops, I forgot my squared. The bottom two, perfect square 16 minus perfect square x squared. How do we factor that one? Nope. Nope, you're doing it backwards, Matt.
4 minus x.
4 plus x, 4 minus x. If the 16's first, the 4 times 4 has to come first. Okay, next up, that one, what'd you take out? GCF.
8x.
8x, okay, got it. And then what? 8x
And then X
Plus.
five.
5?
Yeah.
Okay. You're not done, I hope you know that. There's still more factoring to go. Like what can factor?
It's all.
The top, do you recognize x squared minus 25 is?
X plus 5, X
Yes, it's the difference of two squares, so just kind of do it again, x plus 5, x minus 5, and then cross this out so you don't look at it. Okay, what about this one? 2 times x plus 4, x minus 4, cross it out, don't look at it. Okay, I think I'm ready to go. I think I've factored this thing till the end. What cancels?
X plus 5.
X plus 5 with an x plus 5, got it.
Then the right, top right, and then the bottom left, are like opposites.
Okay, what about a 4 plus x and an x plus 4? Are they the same?
Oh, yeah.
They're the same. These two can just go, right?
Yeah.
And remember, every time I cancel, I should be putting 1 over 1 and 1 over 1. Now, what about this guy? X minus 4? X, 4 minus x. They are opposites. Put negative 1 there instead of a 1 over 1. Oh, wow. Everything's canceling. Monomial. I got a 1x right here. I got a 2 right there. And I got an 8x down there. What's going to happen? Please tell me 2 over 8 reduces to what?
1 over.
That's just 1/4, right guys?
Yeah.
Okay. What about this x on the bottom and this x on the top? What's going to happen?
Stay the same.
Really? If that said 5 over 5, you'd say cancel them out. It says x over x. Cancel them out, yeah. Cancel them out. All right, what a mess. Okay, careful. Here we go. All right, here's what I see, guys. I see this. I see a 1 times a 1 times a 1 times a 1 times a negative 1.
Negative 1.
That's negative 1. Times an x minus 5, though, right?
Yeah.
Okay, over, what's on the bottom? 1 times 1 times 4 times 1.
4.
I'm getting 4. Okay, that's a monomial, that's a binomial, you can't touch it. Now, if you don't like the negative out in front, then you could run it through and call it negative x plus 5 over 4. But both of these work, and if I were you, I'd just stick with the first one, okay? Yeah?
Yeah.
Okay. Flip. Flip. And now it goes into what? Division. Okay, one more time. I'm getting there, guys. Here it is. Okay. So division is the same as multiplication. Here's why. Because I tried to show you when you divide, you really don't. You multiply by the what? What do you multiply by?
The off.
Not the opposite.
Flip.
What's the name for flipping?
Reciprocal.
Yeah, this goes down here. This goes up here. So it's 14y cubed over 20x. And of course, the first fraction you will not change. Okay. All right. Hey, these are all monomials. Okay, help me. Cancellation. Please tell me you see this.
Y.
Look at the numbers. 14, 18, over 7 and a 20. Come on. What goes into all the numbers?
4.
7, I heard. 7 goes into 7. 1. 7 goes here twice. Okay. What goes into 18 and 20?
2.
2 goes in here what? 9.
9.
2 goes in here what?
10.
10. Okay. Whoa. 2 over what? 10 reduces to what?
1/5.
1/5. Okay. So that's a 1 and that's a 5. I told you this gets messy. So number-wise, what's the answer? Number-wise.
9.
9 times 1.
Yep.
1 times 5. Isn't that 9/5?
Yeah.
Okay, 9/5. Okay, variable-wise. You know, variable-wise, I might just do this. I'm going to clean this up. X squared times y cubed is x squared y cubed. Y to the 5th times x. That's just x, y to the 5th. Okay. Now look at the one fraction that's left over. 9/5 is reduced. What about x squared over x?
It'd be X.
Where?
Top.
On the top. 9x. Y cubed over y to the 5th. There's more y's where?
In the bottom.
By how many?
3. 2.
2. So this would be y squared. 5 y squared. I'm telling you, I think monomials are easy, but I think they're super messy, which means easy. Really easy to make a mistake. Okay. Here we go. Guess what? Monomial, binomial, binomial, trinomial, trinomial. Okay. The two binomials, are they identical? Not even close. Guess what? Start factor. Here we go. That monomial is not factorable. That's multiplication. You gotta flip these. This guy goes here. This guy goes here.
No.
Okay, I'm gonna ask you for the factors in about 30 seconds. Yes, ma'am.
Try and use my phone.
Yep, go ahead.
Yes.
I hope everybody saw this one has a 2, GCF of 2. I think that one's pretty easy. What's that? The bottom left had a 2. How about that trinomial right here? Sophia, what'd you get? Here. X minus 6, x what? Minus 5. Is she right? Negative 6 times negative 5 is 30, and negative 6 plus negative 5 is negative 11. Good. Okay. Zethan, what about that one up there? Okay. Elizabeth, did you get this one? Okay. X minus what? 6, okay. Yeah, I would agree with Elizabeth. That looks good. Okay. Guys, once you factor, it's just like, oh, look at it. I got this number same as this number. Cancel. Tell me what to cancel.
X minus.
X minus 6. For the next minus 6, put 1, 1.
X minus 5.
X minus 5 with x minus 5. Put 1 over 1. What else?
X.
Look at the monomials. 7 times x, 2 times x. Yeah, the x's are gone. Okay, guess what? Number-wise, 7 over 2. Binomials left over. None. Oh, we're done. That's the answer, guys. I thought there was more to it. Okay, the next one, I do not see a fraction in the back, but yes, there is. It's what? It's over 1. There you go. Change division to multiplication. Flip the divisor so the 1 comes to the top. All right. Monomials can never be factored, so I'm half done. I only have to factor 2 more. This one, anybody got a GCF yet on this one? Right here? 3x. Okay, times. Times. What?
It's just
Just
X.
X.
What do you mean it's just x?
3 can't go to 5. Yeah.
Oh, it's just x. I'm sorry. Yes, I'm sorry. Yep. What's left? 3x plus 1. Gotcha. 3x plus 1. All right, got it. Okay, here's the deal. The reason I wanted you to do that one first is look at this one. How do you get a 6x squared? Yes, Delvin.
Plus 5.
Oh, yeah. He's right. You're right. Plus 5. Okay. How do you get a 6x squared? Well, you can do a 6x times a 1x or a 3x times a 2x. See that 3x? I'm guessing, just guessing, that factor, 3x plus 5, is probably this factor. So you know what I'm going to do? I'm going to go with a 3x and a 2x. All right. I'm just trying to outguess this problem. Give me factors of negative 15 to put it here.
3 and 5.
Okay, that's a 3x plus 5. I'm going to try it. I want to try plus 5 followed by a minus 3. Right? Is this right? Inner 10x, outer is what? Yeah, does that add up to the 1x in the middle? Yeah, it's good. Okay, now that you see this, just start multiplying, but don't. Cancel first. What do you, 3x plus 5? 3x plus 5. Okay. I got a binomial on the top, but no binomials on the bottom. So guys, it's 1 times this, and this is a 1 here, I guess. So that's just 2x minus 3 over monomial on the bottom, monomial on the bottom. Do they cancel? No. Listen, you can only cancel when they're on top and bottom. That's when you can cancel. Bottom, guess what you do? It's multiplication, guys. Just multiply. What's this times this? 4x cubed. And now, you've got a monomial on the bottom and a binomial on the top. You can't touch them. How? How do I simplify? Monomial? Binomial. You can't touch anything. You just hands off. Okay. For you to cancel the 2 and the 4, you'd have to factor out a GCF and then cancel. Okay. Last one, guys. Go. See if you can take care of it yourself. I'll catch up to you. I'll be about a minute behind you. Matt? Go. So I'm curious what you factored out on the top left. Top left, what'd you factor out? Negative x. Yes. Take out the negative x because if I see the leading coefficients negative, I take it out. What would be left is x plus 3. You don't have to take out negative x. I just do it because typically it makes it easier. Okay. A 9 minus x is a binomial, but it's nothing special. There's no GCF. It's not the difference of two root squares. How about this guy right here? 2x minus 18.